Friends, so here we are looking at our arithmetic series as well as an arithmetic sequence. And in problem number 25, it does something kind of interesting because it tells you that you have a arithmetic sequence that has a common difference of d. So we're just going to simply write out that each term is going to be defined as this plus 1 and minus 1d. Okay, and we're told that with this particular sequence that there's sums of the sequence that in fact form their own series. It's kind of a turducken, if you will. Okay, so some of our first 2 terms, some of our first 5 terms, some of our first 7 terms, these form their own unique sequence. And then we're asked, based on this sequence, to find its common difference. Okay, so common difference, clearly defined, we're going to call it a capital D, just because I don't want it to get confused with this lowercase d. Okay, so when these sums, it might seem a bit overwhelming at first, seeing as how you're going, wait, it's what's happening. But let's break it down, because this has to have a very unique signature in order for the difference between your sum of 2 and 5 terms and then your sum of 5 and 7 terms to have the exact same common difference. Just happen by happenstance, meaning you can't just choose any value you want for your first term and choose any difference you want and then just have that to work out situation. So let's figure out what that unique situation is and then use that to determine what our common difference is in terms of this D. So, all right. With our sum of the first 2 terms, we're going to just use our handy dandy sum of series. So I'm just going to write it here so you've got it for reference. So we've got that 2 times our first term plus n that. And then we're going to go ahead and write out what it'll be for first 2, first 5, first 7. So for first 2, that u times the difference, again, the lowercase d. And then for your 5th, you're going to be looking at 5 times your first term, looking at 10. And then for 7th, you're going to be looking at 7 times your first, and then that's going to be 21. Quick side note, I absolutely love these differences because it builds on one another. The 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4. That was just totally, I love Pascal's triangle. But anyway, digressing. So we know that the difference between 2u1 sub 1 plus d and then 5u sub 1 plus 10d, that equal and be the same as the difference between going from 5u sub 1 plus 10d to 7u sub 1 plus 21d. So let's figure out what the difference is for this for subtract these two from each other. So I'm going to write it over here. Just kind of set it up like this. Okay, and when I subtract them from one another, I get 3u sub 1 plus 9d. Okay, so that's talking about this difference right here. And then let's do it again. And 21d and the 5. Okay. And when we do that, we end up with 2u sub 1 and d. Okay. So that's talking about that difference. Okay. So what that means is that we're saying the difference between your second and your third term in this newly established and recognized sequence. Sorry about that, guys. Here we go. Okay, so we're saying that the difference between our first 2, so 3u sub 1 plus, then you have your 2u sub 1 plus 11d, those two are supposed to equal each other in order for this to make a sequence. So let's set them equal to each other so we can figure out what this unique relationship is between the first term and the common difference of what we originally started with. It's going to have a purpose. Okay, so let's go ahead and set them equal to each other. So I've got equal to 2u sub 1 plus 11d. So I get everybody onto their same respective sides, and I end up with u sub 1 equals 2d. Aha! This is very important. This means that in order with the sum of the second, or the first 2 terms, sum of the first 5, sum of the first 7, to in fact work, that initial term has to be twice as the common difference. So again, I can choose whatever first term I want. There has to be this relationship happening. So with this relationship happening, let's go ahead. The first, second, and third term of this newly created sequence would in fact be. So I'm going to rewrite my sum of the first two terms with regards to replacing. I'm going to substitute 2D for where I have, make sense? So there's my 2u sub 1, and then there's my 2D. So I'm going to replace it. I'm going to substitute it. So I had originally this 2, but now I'm going to have 2 times that, C, and that gives me 5D. Then I'm going to do this again for my 5th term, and I'm going to end up with U and 10D. So that gives me, here we go, 5 plus that 10. Looking at 5 times 2D, that's 10D, plus another 10D gives me 20. And then for my sum of the first 7, which is forming my 3rd term, I'm going to have 7 and 21, which is like this. Okay, because again, I'm just in this relationship first term and the common difference of what I originally started with, and I'm substituting that in. So I've got 14 plus 21, which gives me 35D. Notice what's happening over here, guys. I've got 5D, 20D, 35D. What is the difference between these? 15D and 15D. And so that is how we get our common difference in terms of relating our big D, going back to the relationship between this newly created sequence. So this is first, second, third terms. And what we had originally was just simply a sum of sequences. And that answers your questions.